Hey guys, I'm Anil and this is Group 20. This is our show and tell part 1 for Smart Pantry Pal app. Our app aims to solve the problem of food waste and overspending by giving users a smart way to track their groceries and generate recipes based on what they already own. For this first milestone, we focus on building our foundational structure and integrating core backend services. Our team's responsibilities for this first show and tell were these. We continue to like keep changing the responsibilities so that everybody knows what's working on each part of the code. But for this first and tell, this is what we have. So Jasleen, she designed our MVVM architecture and built the main app and navigation and the fully functional settings page. Then Arsh and I implemented Firebase authentication. Arsh built the email password flow, and I implemented the Google sign-in. And I also worked on taking the lead on the video part and also editing the video. And Andy built the initial AI recipe generator connecting to the Google Gemini API that he used. I think he used Google Flash, Gemini Flash 2.5 Flash. And then Vishwa built the core UI for the budget overview fragment. To start, Jasleen will walk us through the blueprint of our entire application, the MVVM design pattern.
Hi, my name is Jasleen, and I'll go over our app, My Smart Pantries architecture, emphasizing the MVVM design pattern and how app features map onto this structure. I'll show the visual diagram which will illustrate fragments, data flow, and integration with Firebase. Our app follows the MVVM model view model architecture, while keeping this structure because it helps separate UI logic and data handling, which makes the project easier to maintain, scale, and test later. The view layer is everything the user interacts with, things like login, activity, main activity, and fragments for pantry, recipe, budgets, settings, stores. These handle navigation inputs and UI updates, but they don't contain any business logic. Each fragment or activity connects to its respective view model, which supplies the data and the UI needs. The view model acts as a bridge between the UI and the data layer. It manages the app state, handle Firebase calls indirectly through repositories, and expose clean data to the view, often as live data or state flow. For example, auth view model handles sign in and sign out via Firebase auth. Pantry view model communicate with Firestore to load and update pantry items. Setting view model gets and save user preference from Firestore. These setups keep Firebase logic out of the UI, so configuration changes like screen rotation won't interrupt data operations. Model layer, even though if our diagram shows both local and remote data sources, in our Firebase version, the repository primarily uses the remote source, Firebase auth for login and sign up, Firestore for data, user data, pantry items, purchases, and preferences, Firebase Store or the machine learning kit OCR for image-based image item recognition, and Google Maps place for the store location. We can optionally keep room in the diagram as local cache, but in practice, we mostly rely on Firestore, built-in offline persistence. Each repository acts like an interface between Firebase and the view model. For example, Pantry repository will handle all Pantry repository will handle all Firestore read writes for pantry items, and auth repository wraps fire auth operations. This keep Firebase detail out of view model and make it easier to switch data sources later if we need. So when we tie everything together, the user interacts with the view, example presses login, the view model receives the event and calls the function in the repository communicates with Firebase to authenticate or fetch data, the view model observes the result and updates the UI state, the view observes that state and updates the interface automatically. This is the overview we are following for our app.
Hi, my name is Arshdeep. So let's first talk about the proposed schema for our Firestore database for this project. So essentially, we're planning on having six tables in our database. For the first one is the users. So it stores all the user account details and authentication information. Next one is the pantry item that tracks all the items and also log their info like expiry date, quantity, and category, etc. We also give the user the option to save some recipes in the database so they can visit them later. So that's saved in the same recipes table. The next one is the budget. So it manages the user's spending limit, track expenses related to the grocery purchases. The next one is the purchase. So it logs all past purchase details such as item, price, date, quantity bought. And the final one is the shopping list. So the user can store the items they need to buy in a list in our app.
As Arsh and Jasleen detailed, our app uses Firebase for user authentication. Here's the Google sign-in component. We are implementing this using the correct modern architecture. The login activity sends the request to auth view model, which uses the auth repository to communicate directly with the Firebase authentication. When the user clicks the login with Google button, it securely shows the account picker. And in that picker, it'll only show Google accounts already on your device. And after selecting an account, Firebase quickly authenticates the user and the app successfully navigates to the main activity that Arsh talked about. This demonstrates the first major working piece of our backend, connecting our app to a Firebase project.
So for this show and tell, I worked on the login activity. So I worked on it with Anil. So the part I implemented was logging and signing up with the email and password using the Firebase authentication. And as you can see, I include some screenshots on the right of this slide. And so the future work, we are going to add a few more login options for the users. And the main part that I'm going to work for this project is the pantry fragment. So this is the page, this is a fragment where the user can view all their items in the pantry. And they can edit the pantry list by clicking on any of the items in the list and also delete it there. And you can add the items in the pantry using manually, or you can scan the receipt and add it there. You have the option. So the main part for this fragment would be scanning the receipt and extracting all individual items and logging that into the database. And yeah, so we are also including future plans like I'm going to add a delete option, implement the scanning receipt and scanning of the barcode, and store everything in the database. Thank you.
This is my short demo for the AI recipe suggestion feature in our Smart Pantry app. In this version, we integrate Google Gemini 2.5 Flash into the Recipes tab to automatically generate complete recipes from pantry ingredients. Here on the emulator, when I click the Generate Recipes button, Gemini takes a few basic ingredients, in this case eggs, milk, and flour, and returns 3 short, easy to follow recipes. Right now, we are using example data to show how it will look in the future. Each recipe shows the name, a list of ingredients with quantities and amount, and concise instructions on how to make it. The design is intentionally clean, showing each recipe in a single card for quick reading. In the next version, we are going to connect this directly to the pantry database so it gets real data from receipts that users uploaded. Also, they will have an option to choose which ingredients they want AI to suggest the recipes from. Another idea is to let Gemini suggest dishes that require a few extra ingredients and show which ones the users needs to buy. This will make the recipe suggestions more personalized and realistic for meal planning. That's it for this update, and thanks for watching. This feature brings AI closer to helping users cook smarter using what they already have.
Hello, I'm Vishwa Venkateshwaran. I worked on the budget overview part of the project. So my goal was simple. It's just to create like a view where the user can see their purchases, how much money they've spent, and how much money they have remaining for the rest of the month. And other like feature includes like the ability to like sort by both the date and the store, but that's going to be added at like a later time. Just for like the initial, I guess, draft for the first show and tell, this is what I have so far. So you can see like this is the overall like I guess goal. You can see how much money they've spent, their total limit, and of course the difference, so how much money they have remaining for the rest of the month. This is automatically, the recent purchases are automatically sorted by the date, but they'll also have the ability to like sort or like filter by the store. And with the button here at the bottom, the plus button, they'll have the ability to add new purchases. So yeah, that's what I was going for, and pretty simple.
Hi, so my name is Jasleen and I worked on the initial setup of the app. I created a navigation view and added these fragment in the home fragment, recipes, budget and pantry, so everyone can start working on them. My main focus is this setting page in which I added this user profile where user can add their name, age, phone number, gender, and this is the email basically they signed up with. Dietary preference for the recipes, user of measurement they want to display, and the theme light and dark. It also works. And if you want to enable and disable notification, this is only the first basic iteration that we have for settings. As we develop other fragments and we might add more settings based on those. I also connected this activity with the Firebase database. Every user have their own users table and it shows all the information here that was saved in the settings page.
That concludes our component demonstration. As we have seen, our team has successfully built the fragmented components required for the first part of show and tell. We have a working authentication, a successful connection to both Firestore and the Gemini API, and the Core UPI for every major feature. This is a very strong foundation. For show and tell 2, we will be focusing on integration, data persistence, and UI refinement. First, we will implement the room database. Arsh will connect the pantry fragments so that the list is no longer static, but actually saves and retrieves items from local storage, as shown in the mockup that I will show you guys after this slide. Next, we build our key demo-heavy feature, the AI receipt scanner using Firebase ML Kit. This will automatically scan a receipt and parse the item names, prices, and quantities. Finally, this live scan data will automatically populate both pantry and the budget. This will connect to Andy's Gemini recipe generator, allowing it to suggest recipes based on the actual ingredients you've scanned, and feed that data to Vishwa's budget tracker. We will also introduce the new clean UI design you will see in the mockups that I'm about to show you guys.